All right, welcome back. This is Mr. Anderson from Keller Community College for Math 130 Statistics. Today what we're going to do is cover confidence intervals for the average when the standard deviation is unknown. And that's going to be common when we take a look at a small sample and we don't know what the standard deviation is for the entire population. So all we are left is with our small deviation or standard deviation from our small group. Because we can't really know the entire population, so what we're going to use is something called the t-distribution, and the t-distribution is based on something called the degrees of freedom. Now, the t-distribution is a new chart that's located in the back of your book on page let's see here, page 786. So it might be useful to go and get your book out and look at page 786 and take a look at that t-table. Now you'll notice that the t-table has pictures of some curves on the screen, and it might be good first of all to talk about the similarities and differences between normal distribution and the t-distribution family of curves. Now, the big similarity is that, well, let me get to my pen here. The big similarity is that both the t-distribution and normal distribution curves, they're both bell-shaped. So they're both going to look like normal curves, except that the t-distribution is going to be probably a little wider based on the pictures that you see in the book. The normal distribution and the t-distribution are both symmetric about the mean. And also the mean, median, and mode, all of those. The mean, median, mode are all at the center. And they're symmetric around the center, and this would be considered, the mean is considered the 0 point because it is 0 standard deviations away from itself. And also the fourth similarity is that the curve, the t curves or the normal distribution curves, the curve never touches the x-axis. But there are three differences. First of all, the variance is greater than 1. The distribution is based on the degrees of freedom. So if you want to see the distribution, you're going to find out a little bit more about the degrees of freedom, but all of these curves, these families of curves, that can be, very low and spread out or very, much normal, all these families of curves are based on the degrees of freedom. And number 3, the biggest difference is that as the sample size gets bigger, as the sample size gets bigger, the t-distribution approaches normal. So you'll see that in the book and on the table that the curve is going to start out pretty much not looking normal, but as you get more and more of a bigger sample size, that curve will start to get more and more normal. So at first the t-distribution doesn't look like a normal distribution, it looks kind of flat, but it will get better and better. Now the degrees of freedom. So this whole t-distribution is based on degrees of freedom. It's the second difference in our differences list. It's up here at the top. The t-distribution is based on our degrees of freedom. So what are degrees of freedom? It's the number of values that are free to vary after a sample stat or after a sample statistic I'll just put stat for statistic is computed. So, what does that mean? Degrees of freedom, the number of values that are free to vary after a sample stat is computed. Now you may want to pause the video here in case you need to copy any of this down, because I'm going to move this down and draw some pictures to kind of illustrate this here. So, what are the degrees of freedom? Now I can do so with some pictures here, and let me get this ready here. Let's say you're doing group work, and you're doing group work with 5 people. Now let's say that you are given to do, you 5 people, so I'm going to indicate these 5 peoples with 5 rectangles here. Each of these 5 people are given 1 assignment to do each. Now all 5 assignments in this group of people is due at the end, and they have to turn in all 5 or they get no credit. Now there are 5 people in this group and they have to do 5 assignments, and we're going to talk about how many of them can vary. Well, in this situation, the first person can say, well, I'm not doing any assignments, so he's not going to do any. The second person says, well, I'm going to do 1 of the assignments. The third person's not going to do any. The fourth person, let's say, does 2 of the assignments. Now, these 4 people got to decide how many assignments they need to do, but this grade-grubbing little student right here, student number 5, is going to have to make up the slack for the others that didn't do it. So in this kind of example here, the 5th person doesn't have any freedom at all if he or she wants to get the credit for the group. So that's going to mean that that 5th person is going to have to do 2 assignments to make up for the others who didn't do their work. So the answer to the degree of freedom problem is, how many people in this group really had choice? And the answer is 4, because the 5th person has to make up the rest. And the same thing goes with statistics. If you're looking for a certain value, every single value up until the last one has the freedom to do whatever it wants, but the last person or piece of data doesn't really have a choice. Same thing if you want to look at maybe a 3-person group and they have to do 10 assignments each, or 10 assignments total. So if the first person does 6 and the second person does 4, then this person really had no freedom to do whatever they wanted to do because all the assignments are done. So the degrees of freedom is always going to be 1 fewer than your sample size, because it's always up to the last person to make up that decision, or the last statistic to make up that value. So the degree of freedom, which we will call df, is equal to the sample size minus 1. And what's important about that is that the table on page 786 is determined by your sample size. And you take your sample size minus 1 and you find your degree of freedom. Now here's the formula for a specific confidence interval for the average when you don't know the standard deviation for the entire population, but you do know your standard deviation for your small sample. So to find the entire population's confidence interval, you're going to take your average of your sample and you're going to add or subtract from that average the t-tail, which is going to be our sub alpha divided by 2. So it's the tail of that graph. We're going to add and subtract the tails, multiplied by your standard deviation of your small sample divided by the square root of your sample size. So now we need to figure out, because we're going to be able to find our standard deviation based on our calculator. Our sample size will be given to us, our average due to our calculator, but now we need to find this value. So to find this value, we're going to look at the table on page 786 for a 95% confidence interval whose sample size is 22. Now, a common mistake is you're looking now at the left-hand side of that page 786, and you go scroll down to the 22, and then move over to the 95. Don't do that, because your sample size is 22, but your degrees of freedom is only 21. So on the left-hand side, you're going to go down to 21, and that's going to be under our DF. And then over here, you're going to find your 95%, and it's either going to be written as a decimal or a percentage, and it is in the book as a percentage. And you're going to look for that number in the table, and that number is 2.080, and we would plug that in here to figure out our problems. And so I'm going to if you might want to pause if you need to copy this down. I'm going to move to the next part of our work here, which is going to be our examples. All right, so here we are moving down to 10 randomly selected people were asked how long they slept. Okay, the average, let me get my pen draw up here. Okay, the average in our group was 7.1. The standard deviation was, in our group, 0.78, and we don't have the data, but assume that all of this is correct from our data of 10 people, and our 95% confidence interval. That's what we're trying to find. So our sample mean was 7.1. Our standard deviation from our sample was 0.78. Our confidence interval, which we will go to our table and find for 95%. I'm going to leave some space here for that. Our sample size is 10, and our degree of freedom is 9. Now what I'm going to do is go to my table on page 786. I am going to scroll down to 9 on my left-hand side column and scroll over to 95%. And I see that that on the T table there, or this is going to be my T sub alpha divided by 2, is going to be 2.262 thousandths. So let's look at our equation. To find our population average estimate, we're going to take our sample average, add and subtract the T alpha or sub alpha divided by 2 multiplied by our standard deviation divided by the square root of our sample size. All right, so here's how we do this. I'm going to first of all type in my 7.1 minus. Now the reason why I'm doing minus and not plus is you're going to kind of see how this all flows into the answer. We're going to have our 2.262 multiplied by our 0.78. Oops, decimal point didn't show up. Make that look more like a 7. 78 hundredths over the square root of 10. Now, if I compute all of this on my graphing calculator, I get an answer of 56 hundredths. So I got 7.1 minus 56 hundredths, and that gives me about, on the lower end of side, people were getting, with a 95% confidence interval, about 6.5 hours of sleep. Now the reason why I did the minus on this side is because I can get this closer to the format of our answers, because instead of putting plus or minus, they're going to want to see that average between the minus and between the plus. So here we have our 7.1 plus, and I'm going to shorten up my work a little bit. Instead of rewriting all of this, I can put my 0.56 and then drop my answer way down here after I do my calculations. 7.1 plus 56 hundredths is going to be 7 and 66 hundredths. So the population, based on my small sample, with a 95% relative confidence that we're going to be between 6.5 and 7.5 hours of sleep. And that's very similar to the Z confidence intervals we were finding earlier. Now what I'm going to do is, again, pause this if you need to copy it down, but I'm going to move to my next problem, and this problem is going to deal with the raw data. Now in this, it says here the data represents the number of home fires started by candles for a few years. and we're going to find the 99% confidence interval. Notice it's 99%, not 95%, so those get changed. Make sure you look at the problem very carefully, because this is an easy mistake to make if you look at the wrong confidence interval. All right, now you'll notice that we need a couple things for our problem here. We need our average or sample we need our sample average. We need our sample standard deviation. Our confidence interval is 99%, which I'm going to grab from the table. Our degrees of freedom is n. Sorry, our sample size is n, which is 7 in this case, because we got 1, 2, 3, 4, 5, 6, 7 pieces of data. So our degrees of freedom is going to be 6. So we haven't done standard deviation in a while, and in fact I taught how to do standard deviation on a table, but it's time to now cut to the chase and do standard deviation on a graphing calculator. So we're going to run these through step by step. Now it's important to write down these steps here, because as soon as I get to my graphing calculator, all of this writing will go away and I'll have to rewrite it again. So I want to show you, I want to write down the steps with you, then you go to the graphing calculator and we'll get done what we need to get done here. So we're going to have stat, enter. So hit the stat key and then hit the enter key. The stat key and then the enter key. So write the steps down. And then step 2 is to enter the data. And you're going to enter that into list 1 like you would spreadsheet, and I'll show a demonstration of this. And then after you've entered the data, these buttons that are in these makeshift rectangles are, sorry, I wrote star. These makeshift rectangles, these buttons are what you click. You'd hit the stat, then the right arrow key, then the 1, then the enter key again. And this will give you your 1 var stats. Stat, right, 1, enter. Okay, and then what you're going to do is record your X bar, which is your average from your sample, and you're also going to record the capital S, X, which is going to be our sample standard deviation. All right, again, write these steps down because these are going to go away as I click off to get to my graphing calculator little application here. All right, so let's go review here. Our first step was to go to stat, and the stat button is located in the middle of your screen. Then hit enter. We're going to type in our data, so I can use my keyboard, which is kind of nice here, instead of clicking on the calculator's numbers on my application. Just type it in and then hit enter after every single number. If you make a mistake, you can go back and type in over it. And now we have our 7 pieces of information. Alright, so now we've typed in the information. We're going to click on the stat key, which is in the center of the calculator, the right arrow key, the 1, which stands for our 1 variable statistics, and then enter. And now we have our average, 7041.4. We're going to round to 1 more decimal because of our boundaries to go 1 beyond the data set. And then our standard deviation for this small sample is 1,610.3, or 3/10. All right, so let's go back to the screen draw here, which freezes my calculator. I can't actually work the calculator in this at the same time. So now let's write down all the important information again. Our average is 7,041.4. Our standard deviation is 1,610.3. Our confidence interval is 99%, and based on our sample size of 7 and the degrees of freedom, which is 6, if I look on the table, that's going to give me 3.707, 707 thousandths. So I'm going to type this into my equation for my mu, and I'm going to do this a little shorter here since I have a little bit less room. So take my sample average, plus or minus our confidence interval based on our t-table, multiplied by the standard deviation divided by the square root of our sample size. Make sure not to put a 6 there. Okay, now if I compute this on my calculator, which I will assume that you can do, you'll get a rounded answer of 2,256.2. So you get an answer of your average being yep, there we go. Your population's average is going to be 7,041.4 plus or minus 2,256.2. So in a given year, and you'll see that this is a pretty wide interval here, but it's because we had a small sample and because we wanted to be 99% sure, candle-related fires are going to be between 4,785.2 and 9,297.6. So yeah, that's a very wide interval. But we only had 7 years of data, and we wanted 99% confidence interval. So it's going to be a wide interval because we want to be sure that the answer is between here. If we wanted a 90% confidence interval, this would be shorter because we would be able to say, well, this is very conservative right now. So, trying to be as accurate as possible means, look, it can be anywhere between here and here. We just don't have enough data to show anything else otherwise. All right, so for our last page here, again, copy this down. You've now seen 2 different distributions. And one of those distributions is called the Z distribution and the T distribution. So the question becomes, when do I use one versus when do I use the other? And it pretty much comes down to this question. Do you know your standard deviation of your entire population? And if the answer is yes, then you're going to use your Z distribution. And if your answer is no, and we don't know our standard deviation from the entire population, and we're going to have to find it from our small sample, then it's going to be this, which is going to be our T distribution. What's really important is that you're probably going to be doing this more than not, because when you're doing your own data for your own company or your own studies, you're not going to be able to get the national average or national standard deviation unless it's told to you, unless you have that given. So what we have here is a problem where you have a sample of data, and this will show up in your homework, and you're going to you're going to have to find all of this by typing it into the calculator. So you're going to need your X bar. And here's the question. According to this question, will you use a Z or a T distribution? Now read the question to yourself and then see which you're going to use, because you're still going to need a confidence interval given in the problem. But the question is, will the standard deviation be an S or the lowercase sigma? And we're still going to need to know our sample size no matter what. All right, now from the problem, since we were told that the standard deviation is given, we're going to use a Z distribution. So we're going to not need degrees of freedom. Our Z distribution is going to be very nice because we can find out our average from adding all these up and dividing by the total. Now the total number of numbers in this group is 31, and it's a coincidence, not our commonality, that the standard deviation is going to be the same as our standard deviation is going to be the same as our sample size. So it's an anomaly in this problem. Don't get used to it. It won't happen that often. So 90%. If I now look at my Z chart, now you're looking at the front cover of your book here, you're looking at 0.9500 in the front cover of your book because we want that tail, the Z sub alpha divided by 2, which is going to give us 1.65. Now if you add up all the numbers and divide by 31, you're going to get 43.5, and we're going to round to this number because we are going to round to one more decimal than the data set. So going back to the previous section, our mu is going to be equal to Z. Notice that's not a T there. sub alpha divided by 2 times the quantity of our standard deviation, which we know in this case, divided by the square root of n. What did I miss here? Oh, I missed something here. I'm sorry. Let me spread that out here. I forgot that this is going to be, instead of mu, this is my x bar. I have to take my sample average plus or minus z sub alpha divided by 2 multiplied by our standard deviation divided by our sample size rooted. So there it is. Now this equation looks the exact same to the one we learned today, except it's the letter t instead of z. So, and the difference here is that we had to, have the degree of freedom for our standard deviation. So let me just quickly compute this problem out. You may want to pause this before going any further to see if you can get this answer before I reveal it. So press pause now. All right, if you've unpaused it or you're just letting to see this roll, your answer is 1.65 for our confidence interval there. Our numerator is going to be our standard deviation, and our denominator is the square root of our standard deviation, which by coincidence was the same number given in the problem. So this makes 43.5 plus or minus 9.2, if you computed that correctly, which gives me a book answer of the mean is between 34.3, that's subtracting 9.2 from the 43.5, and the mean is also underneath 52.7. So that's 43.5 plus 9.2, 43.5 minus 9.2. Now, before I go on and show you the last example here, I want to show you something on the graphing calculator. Again, copy this down if you need it. Here comes the graphing calculator. Okay, now, some of you thought, like, well, instead of me adding up all these numbers and dividing by 31, why don't I just use the list? Which I would suggest is a pretty good idea. Now, to save time a little bit, what I first want to do is clean out this list. Now, one way to do that is to move over a number and hit delete. But the faster way is to go to the very top of the list where you see all these listed and hit clear, then enter, and everything goes away. Now, you can start typing in 47 and 95, but I've also kind of got this programmed in a list, so I've also, just to save time, I've typed all these numbers in. And you can scroll down and check out your numbers. But you can do your stat right 1 enter to find your average, which was 43.5. But you'll notice that I may have made a rounding mistake here by going 43.5. I should have went 43.4. No, I'm sorry. 43.5 is rounded correctly. Wow, excuse me, I had a little brain spasm right there. So you'll notice, like, well, isn't there a way that the calculator could do more for us? Well, yeah, there is. Let's go to the stat here for a moment, and let's move over to the tests. Now, you'll notice that right at the bottom, number 7, is the z interval. Now, that's super awesome. The z interval is great because what we're going to do here is we're going to get our information here, and we're going to see what the calc can do for us. Now, the data is right in our stats, and it rounded our we have to type in, now this would normally be set at 0, but we type in whatever we want our standard deviation to be. And since on the calculator it was 30 point something, we rounded that up to 31. Now, make sure this is going to be list 1, which it is by default on your calculator, and the frequency level of this is 90%, so 0.90. Now we move down to calculate, and this will do all the calculations for us and give us our lower bound, which we found was 34.3 rounded, and this is 52.6. Now you'll notice that this is where the rounding error comes up because the calculator has some different rounding numbers than our table in the book, so that's why the book always gives different answers sometimes for graphing calculator use. So check it out. The z interval is done on the calculator. It finds our average of the entire set and also the standard deviation of that small sample set. All right, pretty nice little feature. So to review how I got here is I typed in all the data into my list 1. I went stat all the way to tests, and I scrolled down to 7, hit enter. I made sure that this was not a 0 because that's how it starts out on your calculator. Make sure it's the standard deviation that was given in the book. Then we find our frequency list, and we type in our confidence interval, hit calculate, bloop, and it gives us our answer. We'll be able to do that too for our t as well. Let's go to the last part here. And again, I'm going to move this down and do the last problem with you. Hold on. Okay. There's a small number of students who belong to dance companies at each of several randomly selected universities. Estimate the population average size of a university dance company with a 99% confidence interval. So again, you'll see that we have no standard deviation given in this problem, so here are the things we need to solve the problem. We need to find our average, we need to find our standard deviation. Notice it's our lowercase s because this is our small sample. We're going to need to find our confidence interval, which is given in the problem for 99%, which we're going to find on that page 786, using our sample size of 19 people and our degrees of freedom of 18. Now, if I look at the chart, on the left-hand side, 18, and on the top side, the 99% gives me 2.878. If I add up all these numbers and or type these into a calculator and find out our average, because it's adding them up and dividing it by 19, you get an average of 29.8. And our standard deviation is going to be, of this small sample, 6.2, which means that our average for our entire population is going to be our sample average plus or minus our t sub alpha divided by 2, which is 2.878, multiplied by the standard deviation divided by the square root of our sample size. So let me go through this quickly here. You may want to pause it now to see if you can do the work and then come back and check it out. Okay, 29.8 plus or minus 2.878 multiplied by 6.2, which is our standard deviation of our small sample, divided by the square root of 19. Crap, I did that mistake that I was worried that you would do. Don't divide by the degree of freedom. Divide by the sample size. And yes, that's a 19. Sorry, my draw doesn't have an eraser in this program. All right, so I got 2.98, looking at my shame there, plus 4.1. This whole thing compacts down to 4.1. So 29, crap. Did I say 2.98? I meant 29.8 plus or minus 4.1, which means that if I subtract the 4.1, gosh darn it, if I subtract the 4.1 from the 29.8, I get 25.7, which is between our average mu. And if I take 4.1 and add it to 29.8, I have 33.9. Woo! So the average is between 25.7 and 33.9 for a number of people in a university on a dance company team. Whew! Now, I'm going to show this to you on the calculator. Again, please copy this down if you need it, and bye-bye. Let's go take a look at the graphing calculator. Now, again, to kind of speed things up a little bit, I did already program this list into the calculator, so I'll call it back. And there it is. There's the list of all the pieces of data. And I'm going to go 2 to the right. Whoops. Sorry, I have to hit the stat button and click 2 to the right. Now you'll notice there's no t-test here. You're right, there's no t-test except I want the t-test way down here. I want the t-interval test, right? And you notice at the top here, well, we have a z-test and a t-test. And these two buttons, I'm telling you, these are actually to find the numbers that you've been looking up in the back of the book and the front of the book. It's just that I like using the book because it's the calculator is rounding errors, and That's why the book also has these extra things. So I've been ignoring these two right here because you've got tables and you're going to have them, so use them. And then we're going to go to our t interval, hit enter, and you'll actually see that there's less stuff there. We've got our list is in data list 1 and our frequency is 1, but we need to change our confidence interval to 0.99 because our last problem had it at 0.90, and then we're going to click on calculate, and then here we go. Bam! Takes a little bit of time here. And there we go. 25.7, which this calculator you see with a little rounding error, 25.8, and 33.9. So you'll notice that there is some rounding error, but it's well within the margin that's acceptable for tests and homework. So thank you. I hope you learned something new about the graphing calculator and about doing these tests. To wrap up Chapter 7, Z interval tests and T interval tests. Thanks for watching.